Bluetooth. Bluetooth is a short-range wireless technology that lets devices communicate with each other over distances up to 10 meters, sometimes more. It uses radio waves in the 2.4 GHz band to send small packets of data back and forth between devices. You've seen Bluetooth in action if you've ever paired wireless earbuds with your phone, connected a wireless game controller to a console, or transferred files between two smartphones. Bluetooth uses a process called pairing, which creates a secure, one-to-one connection between two devices. Once paired, they remember each other and can reconnect automatically in the future. Most modern Bluetooth uses something called Bluetooth Low Energy, or BLE. BLE consumes much less power, making it ideal for smartwatches, fitness trackers, or wireless keyboards that run on small batteries. However, Bluetooth isn't meant for large data transfers, just short bursts of information like audio signals, input commands, or sensor data. The downside? Interference. Bluetooth operates in the same frequency range as Wi-Fi and microwave ovens. That's why sometimes your audio crackles when you're cooking while listening to a podcast. NFC. NFC stands for Near Field Communication. It's a type of wireless communication that only works over extremely short distances, typically 4 centimeters or less. It's based on older RFID technology and is designed for fast, simple interactions between devices that are physically close. You've used NFC if you've tapped your phone on a payment terminal, scanned a travel card at a subway gate, or exchanged contact info with another phone just by placing them back to back. NFC doesn't require pairing. One device sends a signal, and the other receives it instantly. It's almost like whispering directly into another device's ear. There are two types of NFC modes: active and passive. In active mode, both devices generate their own radio frequency field. In passive mode, only one device actively transmits, and the other just listens, like an NFC tag that opens a website or Wi-Fi menu when tapped. Because it's so short range, NFC is actually more secure than many other wireless methods. Someone trying to intercept an NFC transaction would have to be standing uncomfortably close, like right next to you. That makes it useful for contactless payments, digital ID cards, and secure authentication. Infrared, IR. Infrared communication uses invisible light instead of radio waves. It was one of the earliest forms of wireless data transfer in consumer devices. You've seen IR in your TV remote. When you press a button, it sends a beam of infrared light to the TV, which receives the signal and performs the command. Infrared requires line of sight. That means the two devices need to be pointed directly at each other, with no obstacles in between. It's directional, like shining a flashlight. This makes IR very limited in range, usually less than 5 meters, and vulnerable to interference from sunlight or other bright light sources. In the early 2000s, infrared was also used to transfer files between mobile phones, but it was painfully slow and clunky. Today, IR is mostly used for remote controls, air conditioner panels, and other low-bandwidth, single-function devices. The advantage of IR is that it's cheap, easy to implement, and doesn't suffer from radio interference, but it's being replaced by more flexible options like Bluetooth and Wi-Fi in most modern gadgets. Zigbee. Zigbee is a wireless communication protocol designed specifically for smart home devices and low-power IoT systems. It's optimized for sending small amounts of data over long periods without draining battery life. Zigbee operates in the same 2.4 GHz band as Bluetooth, but uses a mesh network structure. In a Zigbee mesh network, each device, like a smart bulb, sensor, or plug, can relay signals from other devices. So instead of each device needing a direct connection to your central hub or router, the signal can hop from one device to the next until it reaches its destination. This extends the coverage and increases the reliability of the entire network. For example, if your smart thermostat is too far from the main hub, the signal might bounce through a smart plug in the hallway and then a light switch in the kitchen to reach the thermostat. That's the mesh at work. Zigbee's strengths are its low power usage and scalability. You can have dozens of devices communicating efficiently without crowding your main Wi-Fi. But Zigbee requires a dedicated hub, like a smart home controller, to manage the devices. And since different manufacturers sometimes implement Zigbee slightly differently, not every device works with every hub out of the box. Z-Wave. Z-Wave is similar to Zigbee but uses a different frequency, typically 908 MHz in the US. This means it avoids interference with Wi-Fi and Bluetooth, which operate at 2.4 GHz. Like Zigbee, Z-Wave is designed for smart home automation and low-bandwidth device communication. It also uses a mesh network, where each device can pass along messages to extend the signal range. Z-Wave has slightly longer range per device, up to 100 meters in open air, and can support up to 232 devices in a single network. It's known for strong interoperability. Z-Wave devices must meet strict standards, so a Z-Wave motion sensor from one brand can work with a Z-Wave hub from another. That's not always true with Zigbee. However, Z-Wave networks are a bit slower than Zigbee and can be more expensive due to licensing fees. Still, many professional smart home systems rely on Z-Wave for stability and long-term performance. Z-Wave and Zigbee don't compete directly with Wi-Fi. Instead, they complement it by handling background tasks like monitoring doors, adjusting lights, or triggering alarms, while Wi-Fi deals with video streaming and internet browsing. Wi-Fi is the most common wireless technology used to connect devices to the internet without physical cables. It transmits data using radio waves in two frequency bands, 2.4 GHz and 5 GHz. The 2.4 GHz band offers wider coverage but slower speeds. The 5 GHz band is faster but has a shorter range and doesn't pass through walls as easily. When you connect your phone or laptop to Wi-Fi, you're joining a local wireless network, typically managed by a router. That router acts like a traffic controller, directing data between your device and your internet service provider. Most modern routers also support dual-band or tri-band Wi-Fi. Wi-Fi standards are labeled by numbers like 802.11n, 802.11ac, and 802.11ax. The most recent version is called Wi-Fi 6, 802.11ax, which improves speed, range, and the ability to manage many devices at once, perfect for busy homes with smart TVs, game consoles, and smart home devices all connected. One important thing, Wi-Fi is fast, but it's also vulnerable. If your network isn't secured with a strong password and encryption like WPA3, outsiders can connect to your network and potentially access your data. Li-Fi. Li-Fi stands for light fidelity. Unlike Wi-Fi, which uses radio waves, Li-Fi uses visible light to transmit data. It works by rapidly modulating the brightness of LED lights in a way that's invisible to the human eye. A Li-Fi-enabled device picks up these changes using a photodetector and decodes the data. Li-Fi is incredibly fast. In lab tests, it has reached speeds over 200 gigabits per second. That's faster than most fiber-optic internet connections. But it also has limitations. Since it uses light, it can't pass through walls or work in complete darkness. It also requires a direct line of sight between the transmitter, the light source, and the receiver, your device. Still, Li-Fi is promising for certain environments, like hospitals, where radio waves might interfere with sensitive equipment, or on airplanes, where it could reduce network interference. In homes and offices, Li-Fi could complement Wi-Fi in specific rooms where ultra-fast and secure communication is needed. Cellular networks, 3G, 4G, 5G. Cellular networks use radio towers to provide wireless coverage across large geographic areas. Your phone connects to the nearest cell tower, which then routes calls, messages, and internet traffic to and from your device. Each generation of mobile technology has improved speed, capacity, and latency. 3G was the first network fast enough for mobile internet browsing and video calling. 4G brought speeds fast enough for HD video streaming, mobile gaming, and high-speed downloads. It uses technologies like LTE, long-term evolution, to achieve this. 5G is the current generation, ultra-low latency, and the ability to connect more devices at once. It uses a mix of low-band, mid-band, and high-band frequencies. High-band 5G, known as millimeter wave, can deliver gigabit-per-second speeds, but only over short distances and with clear line of sight. 5G opens the door to applications like autonomous vehicles, remote surgeries, real-time augmented reality, and ultra-dense IoT networks in smart cities. However, it also requires a dense infrastructure of small cell towers, especially in urban environments. Satellite Internet. Satellite internet connects you to the web using satellites orbiting Earth. It's ideal for rural or remote areas where fiber or cable lines don't reach. Traditional satellite systems use geostationary satellites positioned around 35,000 kilometers above the Earth. These systems have global coverage, but because the signal has to travel so far, they suffer from high latency, usually over 600 milliseconds. This delay can be noticeable in online gaming or video calls. Download speeds are typically slower, and upload speeds even even more limited. Data caps and higher costs are also common. A newer generation of satellite internet, like Starlink by SpaceX, uses low Earth orbit (LEO) satellites, which orbit at around 500 to 2,000 kilometers. Because the signal travels a shorter distance, latency drops significantly, often below 50 milliseconds. LEO satellite constellations can provide high-speed internet to previously underserved areas, but they require thousands of satellites working together and constant tracking to maintain coverage. UWB Ultra-Wideband. Ultra-Wideband is a short-range, high-frequency wireless technology used for precise location tracking and fast data transmission over short distances. It operates by sending very short pulses of radio energy across a wide frequency spectrum, typically several gigahertz wide. This makes it resistant to interference and capable of pinpoint accuracy. UWB isn't designed for internet access. Instead, it's used for spatial awareness. For example, Apple's AirTags use UWB to help iPhones precisely locate them, even showing directional arrows as you walk closer. Some high-end smart home devices use UWB for presence detection, like turning on lights when someone enters a room or unlocking a car door when the owner is nearby. Because it can detect movement with sub-centimeter accuracy and doesn't require pairing like Bluetooth, UWB is ideal for secure authentication, hands-free control, and indoor navigation. It's not widely used yet, but as smartphones and wearables continue adopting UWB chips, you'll see more devices using it for advanced motion and positioning features. Wireless charging. Wireless charging uses a process called inductive charging to transfer power from a charging pad to a device without needing a physical cable. It works using two coils, one inside the charger and one inside the device. When the charger's coil is energized, it creates a magnetic field. The device's coil picks up that field and converts it into electricity. This only works over very short distances, usually less than 10 millimeters, which is why your phone has to sit directly on the pad. The most common standard is Qi, pronounced Qi, which is supported by most modern smartphones, wireless earbuds, and even electric toothbrushes. There are also resonant and radio frequency charging technologies that allow for slightly more distance, but they're less common in consumer products. Wireless charging is convenient, but it's generally slower and less efficient than plugging in directly. More heat is generated, and positioning matters. If your phone isn't aligned properly, it might charge slowly or not at all. Still, it's ideal for nightstands, desks, or car mounts, where you want to avoid plugging and unplugging your device multiple times a day. The one on screen? Worth a look, if you like knowing what most people don't.